All right, so let's try an example. So this first one I want to do is f of x is x cubed plus 2. So when you're doing transformations, you're going to first identify what I call the base function, or the parent function, I think they say in Hawks. So which function from those 4 that I wrote down in 4.3, which of those does this most resemble? Does it look like an x squared, an x cubed, a square root, or an absolute value? Well, it's got an x cubed, so it looks something like an x cubed. So that is our base, and I am going to write the stuff. So the stuff that I would like give you, or the stuff that's in Hawks, I'm going to write in black, and then I'm going to fill in our answers with blue. Okay, so this is an x cubed, so that tells me what the shape is. It has to look something like this. It's not a very good x cube, but we get the idea. So in Hawks, they do list them, I think, in this order, and you just click yes or no. The way I always say it in class is I look for adding and subtracting, and then I look for multiplying. So do I add or subtract anything? So I'm adding a 2. All right, so that means there's some kind of shift. So it's either a horizontal shift or a vertical shift. Is it inside of my cube, or is it outside? Well, since it's after the cube, it's not x plus 2 quantity cube, it's x cubed plus 2. It's outside, so that's a vertical shift. Vertical is just exactly like you want. It's not weird like the horizontal. So if it's up 2, that means, or plus 2, that means it's going to be up 2. I don't add anything else, so there's no horizontal shift. I don't multiply anything, so there's no stretches, and because I don't multiply by any negatives, there's no reflections. So all this is an x cubed that's been moved up 2. Okay, so on my graph, I would start with my anchor points. And actually, I wrote these down here, anchor. The anchor points of my x cubed are -1, -1, 0, 0, and 1, 1. So I'm going to put them in black. And just because I can, I'm going to put a couple extra points just to make this, look a little better. Whoops. Okay, so this is my parent function, x cubed. It starts like this. What do? I move it up 2. So I'm going to pick up each point, and it moves up 2. So this one goes up 1, 2, up 1, 2, up 1, 2. So this is x cubed plus 2 is my blue function. It's the same shape, it's just been moved up by 2. Okay, now one way that you can actually think about this, and some students like doing this, I actually kind of like doing both. So from the graph, you're physically picking up each point and moving it up 2. We also know, and I wrote this in the summary, that a vertical shift, x stays the same, y adds 2, right? Because it's on the outside, so you change the y values. X stays the same, y add 2. So x stays the same, y you add 2. X stays the same, y add 2. X stays the same, y add 2. So this column would be the points that you plot. So 1, 3, 0, 2, I read them in backwards order. 1, 3, 0, 2, -1, 1. 1, 3, 0, 2, -1, 1. So it's the same thing I got as when I did it graphically. So I would maybe call this the algebraic way, and then this one would be the graphic way, graphically. Either is fine. I probably will do both most of the time because I don't know which way you guys like and I don't want to tell you how you have to do it. So this is the idea of transformations. Picking 3 starting points that we know exist for a base function and then doing all the changes to the points themselves instead of having to like pick the right points in order to get a good picture of this graph.